Okay, welcome back. This is Mr. Hassan's Maths channel, and I am now answering question number 11 from the May-June 2020 Cambridge 9709 paper 1 variant 2. It's pure mathematics and the A-level syllabus. And here we've got a question about equations of circles, which is something which is relatively new to the Cambridge syllabus. Started in 2020, this was the first year. So the equation of a circle with center C is x squared plus y squared minus 8x plus 4y minus 5 equals 0. Find the radius of the circle and the coordinates of C, the center. Right. In order for us to write the equation of a circle in a format which is easy for us to read from it the center of the circle and its radius, we need to write it in this form: x minus a squared plus y minus b squared equals r squared, where this number here, okay, basically whatever goes inside of the x to make this bracket 0, okay, is going to be the x coordinate of the center. So here a has to go in here, a minus a is 0, and whatever goes inside of b, inside of y to make this bracket 0 is going to be the y coordinate of the center, so that's going to be b. That's the coordinates of the center of the circle, and the radius is going to be the square root of this number. That's after the equal sign. Okay, the radius will be r. Okay, so that is the form of the equation of the circle that we need for us to be able to read from it directly the center and the radius. Now, some people will do that straight away in their head. They will see that the coordinates of the center are going to be 4 and minus 2, which you can see quite easily from this once you've understood what to do. But I would not advise you to just write it down, because there are method marks assigned to writing in this form. And if you did make a mistake and you didn't show any method, you didn't show that you tried to complete the square, which is what we need to do actually to write it in this form, then you might lose method marks, and you don't want to be just throwing away marks. So I would suggest you do this, properly. So you say x squared. I would gather the x term and the x squared term and the y squared term and the y term. And what I would do is I would just add 5 to both sides to get rid of that 5 from this side of the equation. And then I would complete the square for this. So x squared minus 8x, if you complete the square, it becomes x minus, because there's a minus, half of the coefficient of x without the x squared. This, if I expand it, was going to give me x squared minus 8x plus 16. I don't want the plus 16, so I have to take away 16. Always take away the square of this number. Okay, whether this is positive or negative, it doesn't matter. You take away the square of this number. Take away the square of this number. And same here. This is going to be y. There's a plus, all right, plus half of the coefficient. So that's going to become 2 squared. That's going to give me y squared plus 4y plus 4. I don't want that 4 at the end, so I'm going to take away 4. And then this will be the same as this. If I expand this, it will give me exactly y squared plus 4y. Again, always take away the square of this number. Whether it's positive or negative, you always take it away. And that's equal to 5. And now I've got this almost in that form. I just have to take this negative 20 and add 20 to both sides, in which case I'll have x minus 4 squared plus y plus 2 squared equals 5 plus 20, which is 25. So we can say the center of the circle is going to be whatever number has to go in here to make this bracket 0, which is going to be 4. And whatever number that has to go instead of the y to make the bracket 0 is going to be negative 2. That's the center. And the radius is going to be the square root of this number here, which is going to be 5. So the radius is equal to 5, and the center is equal to 4 minus 2. And we have answered part A of this question. Okay, now for part B, it says the point P12 lies on the circle. Show that the equation of the tangent to the circle at P is 4y equals 3x plus 5. Okay, so I'm going to make a little sketch of a circle. I'll put it up here a bit so I've got more space to show my steps. So say that's the center of the circle, and we have our circle. Okay, so the center is 4 minus 2. Okay, and the point P12 lies on the circle. So 1, 2 would be somewhere up here. X value less and y value more. So it's going to be a line that looks something like that. The tangent to a circle is a line which just touches a circle at the point where it's a tangent to it without passing through the circle. So we'll have this type of look to it. Let me just make it a bit more accurate. You don't have to do this. just to illustrate the question for you. So say this is the point P, which has the coordinates 1, 2. This is the center of the circle, 4, -2. We want to find the equation of the tangent. This is the tangent. Now, we know the equation of a tangent, we know that the tangent to a circle is a straight line. The tangent to a circle is a straight line. To find the equation of a straight line, we need two things. We need a point on the line, which we have, 1, 2, that's a point on the tangent. And we also need the gradient of the line. We need the gradient of our line. So we need the gradient, which I'm going to call MT. Okay, the gradient of the tangent. We need the gradient of this tangent. Now, what we should understand, very important law from our understanding of circles from IGCSE, is that when you draw a line from the center of the circle such that it hits the circle at the point where the tangent touches the circle, that will always be a right angle. Okay, so you could think of this line here, if we extend it, this line would be the normal to the circle at the point P. Okay, so the normal to the circle at the point P. And we know that the gradient of the tangent times the gradient of the normal is equal to -1. Or we can say the gradient of the tangent is equal to the negative reciprocal of the gradient of the normal. So we can find the gradient of the normal because we have 2 points on the normal. So the gradient of the normal is going to be given by y1 minus y2, which is going to be 2 minus -2, over x1 minus x2, which is 1 minus 4, which is going to give you 4 over -3. So -4/3 is the gradient of the normal. So we know that the gradient of the normal is -4/3. So therefore, the gradient of the tangent is going to be the negative reciprocal, which is +3/4. Okay, if you multiply them together, you get -1. So to find the gradient of a line which is perpendicular to another line, you change its sign and you flip the fraction upside down. Okay, so the gradient of the tangent is therefore 3/4. So therefore, we can show this equation. So when it says show that, and they gave you the answer, basically, you have to make sure your steps are crystal clear. Don't leave anything like, for the examiner to give them an excuse to take a mark off. So I'm going to use y minus y1 equals m times x minus x1. I'm going to use this form of, or this method. Now, a lot of students like to use the method of y equals mx plus c, and I'll show you both ways. I prefer to push my students towards using this method because I find it just makes life easier eventually, especially when you get to higher levels, when your gradients are made up of pi's and e's and whatever. It makes life a bit easier, that's all. So here we have y minus the y coordinate. So this is called x1, this is called y1. The y coordinate of the point, which is 2, equals m, which is our gradient, which is 3/4, times x minus the x coordinate of the gradient, which is 1. Okay, or the x coordinate of the point, which is 1. So now we can, because we want to have it in this form here, where you see they are integers, what I'm going to do is, I'm going to multiply everything by 4 at this stage. Multiply both sides of the equation by 4. Okay, I'll multiply both sides of the equation by 4. This will give me 4y minus 8 equals 3 times x minus 1, 3x minus 3. So multiplied by 4, the 4 cancelled out. I'm left with 3, so 3x minus 3. And 4y minus 8 equals 3x minus 3. Now we want to write it in this form where 4y is the subject, so we're going to add 8 to both sides. So 4y equals 3x minus 3 plus 8, which gives you 4y equals 3x plus 5, which is exactly what we had to show. So we know we're correct, of course. If you want to do it the other way, there's no problem. You can say, all right, we know that it goes through the point P, which has coordinates 1, 2. So the x, this is like the x coordinate, this is like the y coordinate. So instead of y, I'm going to write 2. Instead of m, I'm going to write 3/4. Instead of x, I'm going to write 1. And then I can find what c is. So this is going to give me 2 minus 3/4 equals c. So 2 minus 3/4 is 1/4. It's 1 1/4, sorry. Okay, 1 1/4. Or you can do it in a better way, actually. You can just say this is like 8/4 minus 3/4, which is 5/4. Okay, so then we have the equation y equals 3/4x plus 5 over 4. And then if you want to express it in this form, we have to multiply both sides by 4. So you multiply this side by 4, and you multiply this side by 4. You're left with 4y equals, the 4 cancels out, so you got 3x plus 5. So both of those answers, or those ways of getting the answer, are perfectly correct. I personally try to push my students when they get to AS and A level to use this method here. It just makes things easier later on. But either way is perfectly fine, of course. So there's part B. We've shown that the equation to the tangent of the tangent to the circle is given by 4y equals 3x plus 5. Now for part C. It says the point Q also lies on the circle and PQ is parallel to the x-axis. So I'm going to just go back to this diagram here. So if PQ is parallel to the x-axis, then the line PQ is going to be a line which passes through P and is going to be horizontal. Okay, so that means Q is going to be somewhere over here. All right, so we want to find, so therefore we know that the y coordinate of Q is 2 because it's along this line, y equals 2. All right, so we got to find the x coordinate of Q. Right, so what we can do here is as follows. We know the y coordinate of Q is already 2. So we got to find the x coordinate of Q. So what we can do here, it says write down the coordinates of Q. So it means it doesn't involve much calculation. Okay, so what we can do here is something quite simple actually. All right, because I know that this line is the midpoint of this line. If I make this as a right angle, this point here, and let me call it M, is the midpoint of PQ. And if it's the midpoint of PQ, then this distance is the same as that distance. So I know the distance between these 2 points, the distance between these 2 points here, let me just get my arrow. The distance between these 2 points here, that's a bit big, 1 second. Okay, between P and M is the same as the distance between M and Q, horizontally. Okay, so the distance between P and C horizontally is the difference between 1 and 4. This is going to be 3. So that distance must also be 3. Okay, so if we think about it, we have P, 1, 2, M, okay, and we have Q, oops. Okay, M is also 2, Q is also 2. We want to find the x coordinate of Q. I know the x coordinate of M is 4. Okay, it's 4, right? Because this is 4, this is, straight. So we know that that's M42. Okay, so I know that the distance between these two, this is the midpoint between P and Q basically. So how do I get from 1 to 4? I have to add 3. So how do I get from 4 to xq? I have to also add 3. So I know that Q are going to have the coordinates 7, 2. Right, so I don't actually have to do any calculation. I could also find the answer by making a pair of simultaneous equations, or I could substitute y equals 2 into this equation here, and I'll show you how to do it that way as well. So to do it that way, where you substitute, we can also do that. So let me just take the equation x minus 4 squared. So you have x minus 4 squared plus y plus 2 squared equals 25. So what we could have done, we could have also put y equals 2 into this equation to find the places where it hits the line y equals 2. So you have x minus 4 squared plus, that's going to be 2 plus 2, which is 4. 4 squared equals 25. So you have x minus 4 squared equals 25 minus 16, which is 9. So you have x minus 4 is equal to plus or minus 3. So x is equal to 4 plus or minus 3. So x is equal to 7 or x is equal to 1. We already know x equals 1 is where P is. Therefore, x equals 7 is where Q is. All right, you could have done it this way as well. Okay, and that's perfectly fine. So there's one method using the visual method, which is based upon just understanding that, from this point, which is halfway between P and Q, which we can work out the coordinates of. it's going to be 4 and 2, okay, that the distance between P and M is the same distance as between M and Q. All right, so you just think 1 to 4, 3 units, 4 to whatever, 3 units, that's going to be 7. Okay, so there we have the answer to part C. Okay, write down the coordinates of Q. Then it says the tangents to the circle at P and Q meet at T. Find the coordinates at T. Okay, so we have our circle. Let me just draw it again because it's a bit messy on that side. So we have our circle. We have the line PQ. This is P, this is Q. We know the coordinates of P are 1 and 2, and Q are 7 and 2. The tangents, the two tangents, so you got a tangent at P and Q meet at T. Okay, so you got a tangent at P and the tangent at Q, they meet at the point T. Okay, so you have a tangent at Q and P. That's not drawn very well, but let me just draw it a bit better. Okay, they meet at the point T. Okay, it's just a sketch, doesn't matter. I would advise you actually in the exam, for this exam, to take in a ruler with you, because and a compass, a ruler and a compass, because it'll be it's normally it makes life easier for you when you write, when you're able to make a sketch that is quite, when you're drawing a circle, it's difficult to do it freehand, so it's going to make life a bit more neater for you when you try to make a sketch to understand what's happening. So the tangents to the circle at P and Q meet at T. Find the coordinates of T. So we already know the equation of this line. We found it in part B. It was 4y equals 3x plus 5. Okay, so this is 4y equals 3x plus 5. All right, now we need to find the equation of the tangent here to find where it will meet. Okay, so we need to find the equation of the tangent here. So we need to know the gradient of this line. Okay, so we know that this is the normal there, and this is the normal there. Okay, so to find the equation of this second tangent, okay, we can work out the gradient of this. Okay, so we can work out the gradient of QC, which is going to be 2 minus 2 over 7 minus 4. Okay, so that's going to be 4 over 3. So the gradient of Q to T is going to be negative 3/4. Negative 3/4. Okay. I guess you could have worked that out because this is positive 3/4, that would be negative 3/4. Anyway, no problem. We can then work out the equation of that line. So you have y minus y1 equals m times x minus x1. So we have the point, which is Q, 7, 2. We have the gradient of this tangent, which is going to be minus 3/4. So we have y minus 2 equals minus 3/4 times x minus 7. Multiplying by 4, 4y minus 8 equals minus 3x plus 21. So we're left with 4y equals, we have minus 3x plus 29. All right, so we want to solve these two equations simultaneously. That's the equation of, this one of the tangents, that's a tangent TQ. Okay, and we got the other equation, 4y equals 3x plus 5, which is the equation of the tangent TP. Okay, so what we can do here now is we can solve these simultaneously. Okay, I can, for example, subtract these two equations. 4y minus 4y is 0. 3x minus 3x is 6x. 5 minus 29 is minus 24. So we can say 6x equals 24. Therefore, x equals 4. Okay, and so that's the x coordinate of t, 4. And for the y coordinate, I can choose any of these two lines I want to. because both of them will meet at that point. So I can choose, for example, 4y equals 3x plus 5. So when x equals 4, 4y equals 3 times 4 plus 5. 4y equals 12 plus 5, which is 17. 4y equals 17. So y is equal to 17 over 4. So we have 17 over 4 as my coordinate for y of t. We can make sure that we're correct by using the other equation that we got. And we can put 4 in here. So we're just to make sure, if you want to, as a check. So 4y equals minus 3 times 4 plus 29. So 4y equals minus 7. 4y equals minus 12 plus 29. So 4y equals minus 12 plus 29. So 4y is equal to 17. So y is equal to 17 over 4. So we know that we're correct. So our coordinates of t are 4 and 17 over 4. And there we have the answer to this question, the coordinates of t. Okay, so that, I think, completes the whole question. Yes, it does. And the paper. So I think the question that mainly was being asked by the student was this one. I hope to understand both ways. So if you want to find other questions from this paper, you can go to the playlist over here. Other questions from the topic of circles, equations of circles from my Cambridge collection of P1 can be found over here. I'll also include a link to my collection of Edexcel equation of circle questions, which are kind of similar to these type of questions. You'll find a lot more of them because it's not a new topic in Edexcel. So you'll find the link for that over there. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.